For this example, let's turn this small space into a kitchen. Many items, such as appliances like refrigerators or dishwashers, can be placed simply by choosing the component and placing it in the model. Let's open the Component tool in the Home tab and place a dishwasher using the first floor plan view. Now let's find an appropriate refrigerator and place that in the model. Finally, let's choose a sink and place the sink into the model. Now we will switch to a 3D view, and it is easy to see that we have a good start to our kitchen. However, at this point in the process, it may be necessary to make custom fitting components such as countertops in order to complete the model. To make custom components, open the Model in Place tool. Now, let's search for a family category that fits the component we are going to make. We can select Show Categories from all disciplines for more options. Since we are making a counter, let's choose Furniture Systems. Now we will name the new component. Let's call it Kitchen Counter. Now in this mode, notice that we are unable to select any other components that are in the model. We are now ready to create forms for our Model in Place component. Once we are in the In Place editor, we can select a type of form that we want to create. We can choose extrusion, blend, revolve, sweep blends, or void form. To make the countertop, let's make an extrusion. To create an extrusion, start by sketching the footprint of the extrusion. Remember, extrusions don't have to come up from the ground. Instead, we can choose a new work plane and make the form come out from the wall. Using the same form, we can make two unconnected extrusions that follow the same properties, like this one around the sink. When the sketch is complete, we can set the properties of the extrusion. We will set the top to be 3 feet and the bottom to be 2 feet 10 inches high. This will give us a 2-inch thick countertop. We can also choose the material. In the Materials dialog, let's choose a tile countertop. When we are finished, we can select the green check mark to complete the form. And in a 3D view, we can more clearly see the form that we have just made. If we are happy with the Model in Place component, we can select Finish Model in order to exit the In Place editor. We are now able to select other components again. We can also select the component we just created and make minor changes like adjusting the extents. To make major edits to a Model in Place component, select it and choose Edit in Place, which will take us back to the Edit in Place mode. Once we are in this mode, we can select the extrusion form and edit that. You can now see that it is important to realize that a single component is made of many different forms, and each form is edited separately. For this extrusion, let's change one of the boundary lines to create a curved countertop. When finished, select the check mark to complete the form. And we can switch to a 3D view to see this change. Since we are still in the in-place editor, we can also add new forms to the component. Let's start by adding a base to the sink's countertop. Sketch the footprint. And set the properties. This time, we'll want the base to go from the ground to the bottom of the countertop. Let's also change the material and pick a wood finish for the base. When we are finished, we can select the green check mark to complete the form, and in the 3D view, we can see our new extrusion. Once again, we are still in the in-place editor, so let's go ahead and add a sweep to the edge of the countertop. First, we will pick a path for the sweep. Let's select the edges of the counter. Then, we will select the green check mark when we are finished sketching the path. Now, to make it easier to draw the sketch, let's change the view to look straight on to the crosshair. Next, select Edit Profile, or we can also load in a profile. This opens all of our drawing tools, and using the drawing tools, we can sketch a profile that will be swept along the chosen path. After making a closed loop sketch, we can change the sweep properties, such as giving it a material, and when finished, select the green check mark. Since we have now selected a path and drawn the sweep profile, we can select the next green check mark to complete the sweep. Now let's change our perspective to more clearly see the sweep we have just created. If we are satisfied with the component, we can select the green check mark to exit the in-place editor. To demonstrate void forms, let's edit this model in-place component and turn it into a wine rack. Select the component and open the in-place editor. Now, choose to make a void extrusion. This form will cut through our solid form. Next, we can set a work plane, which will be the beginning of the void form. Select Pick a Plane and choose the face of the solid extrusion. Now we can draw a sketch of the void that we want to create. The void can be made of multiple closed loop sketches. When we are finished with the sketch, we can select properties for this void. Since the solid form is only 1 foot deep, let's change the void end to be 1 foot. When finished, select the green arrow to finish the model. Now we can see the finished component, which is a combination of both a solid form and a void form. When satisfied, select the green arrow to exit the in-place editor. Before creating a revolve, we will first make a plane that we will use later in the demonstration. To do this, we will switch to a floor plan and draw a reference plane. The line we are drawing is the edge of the plane which goes into the screen. Let's select this plane and name it Example. Now let's create a model in place component for simple demonstration purposes. We will also give this component the name Example. Next, open the Revolve tool and set the work plane to be the one that we have just created. Now show the plane, and then switch to an elevation view so we are looking straight at the plane. Now, using the drawing tools, sketch the shape that we want to be revolved. When finished, let's sketch the axis line, or the line that our profile will be revolved around. Once the profile and axis line have been sketched, we can select the green check mark to create the revolve. We can also select the revolve form and change its properties, for example, its end angle. We can also give it a new material. Now let's experiment with creating blends. To begin, we must create a bottom shape for the form. If we are unable to create the sketch, we may have to change the work plane. Once the base shape is finished, select Edit Top to sketch the top shape. When finished, select the green check mark to create the form. In a 3D view, we can see that we have created a 3D form by blending together two separate shapes over a specific height. To edit the properties of the form, select it, and we can change its height. We can also give it a new material if we wanted. Now let's create a swept blend. To begin, sketch or pick a path for the sweep. For this example, we will sketch one. The path we create can have as many curves as we desire. However, it can only be made from one continuous line with no sudden changes in direction. Select the check mark to finish the sketch of the path. Now, select a crosshair and sketch an initial shape for the blend. When finished, select the other crosshair and sketch the final shape of the blend. When both the start and end shapes along with the path have been sketched, select the checkmark to create the form. This tool blends the initial and final shape together over the selected path. We can also give this form a new material, and remember that each form that we have created can be a void form as well as a solid form. To begin exploring families, let's select the sofa component in the living room. Next, open the Family Editor to see the component definition. Now we can examine all of the component's parts to see how they were made. Select the coffee table, which will then allow us to edit the extrusion. The coffee table was made by extruding a square sketch up from the ground. Now select the side table and open the Edit Extrusion tool. This table was also made by extruding a rectangular sketch above the ground. Next, select the backrest. This time we are given the option to edit a sweep. This portion of the sofa was made by running a sketch along a chosen path. Let's open a family not included in our model and examine it in depth. In the File menu, choose to open a family. Let's choose the shaker bed for this example. Now we can examine how the parts of this component were made. After selecting the headboard, footboard, and mattress, we can see that they were all made from extruding various shapes off of various planes. Now let's open the Family Types dialog. From here, we can select different types of the family in order to examine their parameters. Each type has different dimensions assigned to it. They can also be assigned different materials and finishes. Now let's modify this family to fit our needs. First, save the file as a new family so we don't overwrite the original. Name the new file Bed 4Post. To begin, let's remove the rail on the headboard. Select the rail, then select Delete. Now let's change the pattern of holes on the headboard. Select the headboard and edit the extrusion. Now, switch to an appropriate elevation to edit the sketch. Select the boundary lines and move them into the desired location. Finish the sketch and return to the 3D view to see the changes. Instead of editing or deleting existing forms, we can also add new forms to a family. Select the reference level and under the Home tab, open the Extrusion tool. Now, let's sketch a square that will be extruded to create one of the posts for our bed. When done, select the check mark to finish the extrusion. When done, select the check mark to finish the sketch. Notice that the extrusion starts at 0 feet and rises to a height of 1 foot. Change the extrusion in to 7 feet to extend the height. Now we can select the extrusion and open the Materials dialog. Assign the post the same material as the frame and select OK. Now, in the Reference view, let's mirror the bedpost over the center axis to place another post on the other side. Finally, copy these 2 posts to the other end of the bed. Now, return to the 3D view to see our finished bed. Open the family types and choose a new type to make sure our constraints are still satisfied. In the Family Types dialog, we can also create new types. Under Names, we can see the types already created. Click New, and let's name our new type California King. For this new type, we can now choose a new length and width. Our new type will appear with the other types, and we can apply our new type to the model. When finished, let's save the family in order to keep our changes. To place this component, let's switch to our model. Select Place a Component. Notice that our new component is not available as a type. Open the Load Family dialog and find our bed in the library. Now, place an instance into the model. After selecting the bed, we can change it to a different type in order to get a more appropriate size. We can then select the bed and edit its type properties in order to change parameters such as the materials used. We can create parametric component families to allow us to change their key properties, their dimensions and materials, by adjusting parameters. Parametric families are very useful and easy to work with because they can easily be adapted as needed to meet our modeling needs. Let's start by creating a new Revit family, and we'll add parameters to this family definition that let us dynamically change it. Open the Revit menu and choose New, then Revit Family. We'll start by choosing a template for this new family from the Templates section of the library. Every Revit family is based on a template that specifies the category for this family and any special hosting requirements. Most families can be placed anywhere in a project model, but some families are defined as being wall-hosted or ceiling-hosted. Components from these families can only be placed on the appropriate hosting element. Let's choose the Furniture template to create a new console table with no special hosting requirements. Users of this component will be able to place it anywhere in a project. Before we get started modeling, let's save this new family to the library and name it Console Table. Open the plan view for the reference level. You'll see that there are two reference planes that have already been defined as part of the template. These are center front back and center left right. The intersection of these two planes is the placement point, the reference point on the component that will be placed at the point where you click the mouse as you're placing the object in your model. We'll add new reference planes to define the boundaries of our new console table. First, place reference planes running left to right on both sides of the center front back plane. These will be used to define the front and back sides of our table. Then, place reference planes running from top to bottom on both sides of the center left-right plane. These will be used to define the left and right sides of our table. Now, let's switch to an elevation view. We'll also add a reference plane to define the top of our table. We'll give this one a name, so it will be easy to identify later when we are setting the work plane. Place it and let's name it Tabletop. Let's add some dimensions that will give us the ability to dynamically reposition these reference planes. First, let's create a dimension between the left, center, and right reference planes. We'll set the equal constraint to make sure that the left and right sides are always positioned equally around the center line. Now, we'll add an overall dimension between the left and right sides. We'll use this dimension to control the length of our table. Rather than giving this a fixed dimension, let's add a parameter to this definition line that will let us dynamically change it as a property of the table. Select the dimension, then open the label pull-down in the options bar and choose Add Parameter. We'll leave this set to a family parameter. Give it a name. Let's call it Table Length. Now set this as a type parameter. That means that this dimension will be the same for all components of the same type. To change this dimension, the user would define a new type and set the desired size as a type property. This will be a parameter of type length, and we'll leave it grouped in the dimension section of the properties dialog. Next, we'll add similar dimensions between the front and back reference planes. First, add dimensions that will set to equal to make sure the front and back reference planes are always equally spaced about the center. Then, we'll add a dimension that we'll use to set the width of the console table. Select this dimension and add a parameter to it. We'll call this one Table Width. It will also be a type parameter. It will have the type Length, and we'll also leave it grouped in the Dimension section of the Properties dialog. We can switch to the elevation view and add a similar dimension to set the height of the console table. This one won't need the equality constraint since we want the table to be placed above the reference level. Add a dimension between the reference level and the top reference plane, then add a parameter to this dimension. We'll call this one Table Height, and it will be a type parameter of type length in the dimension section of the properties. Now that we've created parameters to move the reference planes, let's test them to make sure they have the desired effect. Open the Family Types tool. The parameters that we've added in the last step appear in the dimensions sections of the dialog with values measured from the current model. Enter a new value for the table width, then click the Apply button to verify whether the reference planes move properly. Let's try another value. Now, let's change the table length, and again click the Apply button to verify that the reference planes move as expected. We can repeat these steps to systematically test that each of our parameters is having the desired effect on the reference planes. Now let's switch to the elevation view and check out the table height parameter. This parameter is also working properly. Back in the Family Types dialog, we can define a few types with different dimensions that we can use for testing our new table component. Click the New button in the Family Types section of the dialog and enter a descriptive name for this new type. The current dimensions are copied into this type. We can change these values or define another new type and change them there. When we're done, we'll have several different types to choose from. You can see them here in the name dropdown. These will be the names that appear in the type selector. We're now ready to add forms to our component. We can add solid forms or void forms and use any of the form generation methods, extrusion, blend, revolve, sweep, or swept blend to define these forms. To make these forms dynamic and resizable, we will use our reference planes to define key aspects of their geometry. That way, when a reference plane is moved, the forms will be resized too. Let's see how that works. Switch to the reference level plan view and we'll create an extrusion to model the tabletop. Sketch the boundary for this extrusion in the center of the drawing area. Then use the Align tool to move the edges of the boundary and lock them to the reference planes. Do this for all four sides of the extrusion. Click the check mark to finish editing the extrusion. Then, let's switch to the elevation view to set the top and bottom of the extrusion. You see the extrusion we just placed at the reference level. By default, its start is at 0 feet and its end is at 1 foot. Let's use the Align tool again, this time to lock the top of the extrusion to our reference plane for the top of the table. The table shouldn't extend all the way down to the reference level. So let's add another reference plane to control the bottom of the tabletop. Then, use the Align tool to lock the bottom of the extrusion to it. Next, we'll add a dimension to set the thickness of the tabletop. This dimension will extend from the reference plane at the top to the reference plane at the bottom. Always be careful to dimension to the reference planes, not the surfaces of the form. You may have to use the Tab key to select the reference plane when adding the dimensions. Let's set this dimension to 4 inches. We'll leave this set as a fixed value for now, so the tabletop will always be 4 inches thick, regardless of the table height. Now, let's switch to a 3D view and confirm that the form resizes properly as the parameters are changed. Open the family types and choose different types or change the parameters and click Apply. As we make changes, our new tabletop form changes its size based on those dimensions. We can repeat these steps, adding reference planes and creating a new form whose shape is defined by these planes to model another piece of the model. We'll add a pedestal base beneath the tabletop. Switching back to the plan view, you can see that we've added reference planes and parameters to define the pedestal length and pedestal width. Then in the elevation view, you'll see that we've added another extrusion that stretches from the reference level to reference plane at the bottom of the tabletop. Open the family types again. Now we'll confirm that the two forms are responding properly to changes in the parameters. We can also assign materials to each of these forms, either as a fixed material or as a parametric material that can be changed by setting the component's type or instant properties. Select the tabletop form. In the Properties palette, you can see that this form is set to use the materials defined by category. So by default, this form will use the material assigned to the furniture category in the project. Click the material value, then click the small button to open the materials dialog. You can choose one of the existing materials in the list or duplicate a material to create a new one. Let's duplicate the default material and create a new material called Console Table Wood. Now let's give this a brown shading. Close the material dialog and you'll see that the material is assigned to the tabletop form. Now let's select the pedestal form and we can assign this same material to it. As a final step, let's add parameters to material settings for each form, so users of our component can easily change the materials in their project. Select the tabletop form again and click the small button to the right of the materials value in the Properties palette. This button opens the Associate Family Parameter dialog, where we can add a parameter that will let users change this value. Click the Add Parameter button, then create a new parameter called Table Frame. Let's make this an instant property, so the value can be set independently for every instant of this component. This will be a parameter of type material, and we'll group it under the Materials and Finishes section in the Properties. Let's set up a similar parameter for the pedestal. Select the pedestal form and click the small button to the right of the Materials setting. Add a new parameter called Pedestal and set this to be an instant parameter of the type material and group it under the Materials and Finishes section. Now let's save our work so we can load this into a separate project. Let's open a project to load our new component into. Now open the Place Component tool and then select Load Family. In the library, find the family that we just made. Now place an instance of our table into the model. In the Type selector, we can also choose a different type and place that as well. Once placed, we can also select an instance and change its type within the model. Next, we can select an instance and edit its type in order to create a new type with different dimensions. Duplicate the existing type, give it a new descriptive name, and change the dimensions. When finished, select OK. We can also share our Revit family file with others. Anyone can use the Load Family tool to load the component family into a project, then create new types as needed and adjust the type properties to set the dimensions for each type. They can also set the materials for each of the forms, the tabletop and the pedestal, as instant properties for each instance placed in the project.